Hello guys. Today I'm going to be talking about how I'm going to make an air conditioner. Now, I actually had this idea like last year or last year, not sure. And I had bought most of the components to do it. But at that time I was stupid. I thought I could do it with just rubber hoses and some sealant with some hose clamps. No, that doesn't work. It's pretty high pressure and blew up a few hoses and then gave up. I still have the gas, the compressor, some copper tubing, one radiator, that would be the evaporator. So I need to get another radiator, which would be the condenser, and some more copper tubing because this time I'm gonna braze everything together, gas weld it. I'm not gonna take any risks with like normal rubber hoses. So um now I'm gonna show you a PPT which I made 2 years or 1 year ago. And then I think a few days ago I added another part, Plan B. Plan A failed miserably because I was stupid. I wasn't that thorough with the concept, and I tried to do it with just without any brazing. That's why I didn't make any leak-proof joints, and I lost all my refrigerant gas. Yeah, so let's move on to the PPT. Okay, yeah. So this is my presentation, which I made all the way back in 2024, I guess. Not sure. Let's check. Yeah, 2024, 21st of this month. So I guess 5 more days. So it's almost 360 days. It's basically a year, bro. It's fine. Yeah. As I was saying, this was Plan A, the one with the the rubber hoses and the hose clamps. Now, I'm not gonna hate on myself that time. I was a little bit fresh to the concept, and I didn't really know what I was doing. Yeah. Uh. Yeah. Okay. So this diagram is actually still feasible. Okay. So before I had a misconception that I actually swapped the functions of the evaporator and the condenser. Okay. The evaporator is called the evaporator because it is vaporizing the cooled liquid gas or refrigerant gas. It's vaporizing it, so it's called the evaporator. And condenser is losing the heat and cooling the gas such that it condenses into a liquid from a vapor state. Okay, so over here, seeing that this part is the cool part, I'm going to assume that this is going to be the evaporator and it's going to be the condenser. Okay, because the hot gas is being converted into a cool liquid over here, so it's the condenser. Okay, so yeah, I've actually labeled it also. Hot gas, cold liquid. Yeah. So in the evaporator, there's going to be the condensed liquid. It's going to pass through this guy and it's going to absorb heat from the atmosphere around it. And that heat is obviously going to turn this condensed liquid into a gas. Yeah. So, and it's quite the opposite for the condenser. It takes the hot gas, which was heated in the evaporator, and slowly dissipates the heat to the atmosphere around it, and slowly condenses the gas into liquid. Now, this gas is not just air, okay? It's a special type of gas called refrigerant gas. 134A gas, I mean, 134A is the type of gas required for a fridge compressor so it doesn't blow up. Now, it's going to be changing as per the compressor you're going to use. So, now the refrigerant gas is a special type of gas that has like really close vaporizing and condensation points. So it would condense and evaporate quickly in a small change in temperature. Yeah, so that's about it. Yeah, that was plan A. Now this is plan B. So this is just the green materials is just going to be what I need to prove the concept because I'm going to be asking for an additional investment. So I have to convince my dad it's working right, not like before. So now you may ask why are we using a compressor instead of just having a normal pump to move the gas around. Now the compressor is actually increasing, well, it's compressing the air. Now, if you've heard of Gay-Lussac's law, which directly relates pressure and temperature of a constant volume of gas. Higher the pressure, so is the temperature. So if you, okay, I'll talk about why we need a higher pressure over here later. Okay, let me build up to that. So yeah, I'll change that. This is when I had a misconception. Okay, what? Yeah, capillary tube. Okay, now the capillary tube is the really thin tube you see over here. Okay, it's going to be drastically thinner than the other type of tubing we're going to be using throughout the system, and we're going to have a filter dryer over here, which is just going to be a much larger chamber. I called it something that time. I wasn't sure what to call it. I found out the real name today. It's called a filter dryer, and this is called the capillary tube. Okay, now the pressure will increase over here, and the pressure will decrease over here. Yeah, that's pretty much that's pretty much it. So now, why are we increasing the pressure? Okay, so let me just pop up the diagram over here. Okay, yeah. So why are we increasing the pressure with the compressor over here? So that we can increase the temperature. But why increase the temperature? Because see, say it's 30 degrees out here, okay, in the atmosphere, and so is the radiator. There's not going to be any transfer of heat. I mean, that's at least why I'm assuming why we need a compressor instead. So by compressing the air, you're increasing the pressure, and so are you increasing the temperature, which would mean that this would become from 30, maybe 35, 40, 50 degrees Celsius, and it'll easily lose heat to the atmosphere around it. And once it goes back into this, um, I still don't get the science behind it, but I'm assuming that, okay, it's going into the filter dryer, and then it goes into this really thin tube, very, very high pressure, really high pressure, then suddenly a bigger chamber over here, a really sudden drop in pressure and drop in temperature is what I'm assuming. Uh, don't quote me on that. Not sure. Okay. Yes. So that's why we need a compressor, it's a normal pump, to increase the pressure such that the temperature also increases. So yeah, that's about it. Um. Okay. Yes. Now fan. I mean, it's self-explanatory, but okay. So now we can use most commercial ACs actually use a centrifugal fan. Whoa, I swapped the images. My bad. So the centrifugal fan. So what happens is it's actually flinging the air radially. Okay, it's pushing the air perpendicular to the shaft. So it's sucking air from here and pushing it to the side. Now you might ask, what are the advantages of a centrifugal fan? Okay, now they can handle back pressure or resistance easily. So it can handle the resistance offered by coils, radiators, tubing. You get the point. It can handle back pressure. Yeah. Okay. And it's quiet. So it's if you have an AC system at home, like the wall mounted ones, just for a single room, 100% chance that it's going to have this, the centrifugal fan. Now the centrifugal fan, it's quiet, it's efficient, and it's actually pretty compact, so it's pretty good for window ACs and these wall mounted ACs which have to be compact. Now the only problem with them is that they're expensive and they're hard to find. So for this project I'm still going to stick with the axial fan. Okay, now axial fans are just pretty much normal fans. It's pushing the air parallel to the shaft, and well, they're it's cheap. It's not that complicated. They're not as compact, and they can't really handle back pressure that well. So yeah, I feel like I'm talking too much. So I mean, there's not going to be any application-based videos now, as in this video. Okay, yeah. Now I'm going to be talking about how I'm going to braze everything together. Now, brazing materials. Now you will have two different types of gases which you might find available in the shop. That is MAPP gas or butane. I'm not sure what this is. I just learned about it like an hour ago, so I'm not sure. MAPP gas, apparently it's good. It's perfect for this kind of gas welding or brazing. Now, why not butane? Now, butane is, I mean, they'll state that it'll burn at 1800 degrees Celsius. That's more than enough for melting any silver-based rods or copper phosphorus rods. But butane is apparently not that great, it seems. In real world conditions, it's going to lose its heat, and it's not great for brazing any rods that are higher in diameter than half an inch. So it's just not hot enough. That's the problem. Okay. Now I'm sure I'm not half an inch is the like biggest I'm going to go. So I'm sure butane will be fine, but it's best if I find this. So if I can't find this in stock, I'll ask the guy if this is okay for brazing, and then I'll take it. And if there are any different type of materials required to do it with butane, I don't think there is, but yeah, this is that MAPP gas, and this is well the butane-based gas. Yeah. So what do I need? Torch. Okay. Gas. MAPP first option, or last resort butane. Now you might be wondering what oxyacetylene is. Now it's like a really good version of MAPP. It has a mixture of, well, it has oxygen in it too, so I guess it helps burn better because it's uh, yeah, it helps it burn better, and it'll burn at 31 degrees Celsius, and it's industrial grade brazing. It's really good. It's too good for us. It's overkill and expensive. So stick with this if you find this. This is your last resort. Fourth time I'm saying that. Now copper phosphorus rods. This will work when you have MAPP, when you're using this type of gas. But if you're going to use butane, you better stick with silver-based rods because they melt at a lower temperature, and they will form a smoother joint. Yeah, smoother joint. Yeah, copper tubing, fine grit sandpaper for cleaning the tubes, pipe expander and pipe expander. Well, I don't want to buy one because well, it's an additional tool which I'll use very rarely. So if the collars are cheaper, I'm gonna just buy that pipe cutter to cut the pipes, which I'm not gonna need actually. I'm not gonna cut anything. So okay, how to braze? Prep the tubing. Using the fine grit sandpaper, you sand the exterior and the interior of the tubes with a good amount of extra, making sure the good amount of it is well clean. And then you want to use a fine cloth to wipe off any of the residue of the sanded parts because you don't want any loose material on it. You want the solder to come in direct contact with the metal. Yeah. Then hang a wet cloth if you're going to be brazing near some components so that the heat doesn't transfer onto them. Expand the tube, apply heat, and use a pipe expander to expand it. So if you're going to join two um, tubes of the same diameter, then tightly jam the tubes together and heat the tubes till cherry red, and then gently like touch the rods to the joint to see if well it's melting. If it's melting smoothly, then continue and apply the solder equally evenly on all sides and ensure that the solder is covering the edge. So if the solder is covering the edge, that means you've used enough and it should be good enough. Yeah, then let the joint cool naturally with the air. No water, no coolant or any different type of cool stuff. Don't blow air on it also because if it cools really fast, the solder will crack and well, you don't want that because then you lose all your gas. Then clean the joint just to make it look nicer and move on. Yeah, this is a video I actually referred to. I mean, I referred multiple videos to make sure I'm thorough, but cool. I found this the most helpful. I think I'll put the link in the description. Where is YouTube? Yeah. Jumper Man Tech, pretty cool, useful. He had a really nice video, and well, it's pretty specific, so it was good. Yeah. So that's about it for today. Bye bye. So disadvantages of traditional air conditioning systems. Now they recirculate the same stale air. I'm talking about the commercial ones which you use inside your like the wall mounted ones. They consume lots of power. Well, mine's gonna consume more. I feel like it, and they're not very portable. I guess that's fixed. Not sure. So yeah, so they recirculate the same stale air, which is unhealthy. Um, like no oxygen, it's humid. Not really humid. The humidity is actually removed by the evaporator, but either ways. So how can I overcome it? The recirculatory problem. So I can make a system that actually mixes. What I thought here is that make a system that completely uses external air and cools that and pumps it inside. So it's not recirculating the same air. But then I encountered why, because why we recirculate the same air? Because I'm not smarter than a guy who designs air conditioners, right? So it's going to, it's mainly because recirculatory problem. Yeah. Uh, the cooling power. It's much easier to recool already cool air than to cool warm air again. So just for that problem, that's why we recircle the same air, stale air. So this is what my solution was that time. Just one singular duct coming from outside, fan over here, and the air comes from here. Um, One more advantage of having this was that all of the components are outside. All the noise-making components are outside. All the dangerous stuff is outside. So if anything blows up, I'm not gonna die. So yeah, one duct. That's about it. Stellar eliminated, yeah, that was completely group design. Yeah, so because before I was actually planning on obviously I had to have the evaporator inside and the condenser outside, and I need a flexible connection between them through the wall. So I was thinking of using rubber hoses again. Now using a rubber hose here would obviously bring back the old problem of not leak-proof joints. So here everything's going to be brazed and using copper tubing that's close to each other, so you can do that. Yeah, so one, I can completely braze the entire system. Two, all the dangerous components are outside, noisy components are outside, and yeah, that's about it. And the recirculator problem is kind of solved, but it's going to lose cooling power. So the solution was to copy the cooling systems that are used in commercial buildings, which don't have many openable windows. So what they do is that they take some air from outside and mix it with the normal air from inside. So it's not going to be completely warm air from outside. It's going to be a mix of the cool air from inside and the hot air from outside. So this would still reduce the cooling power, but not as drastically as completely cutting off the indoor supply. So yeah, here's the system. Yes, solution. Two ducts, as you can see over here. One fresh air with a flap and one room return air, as in the air from inside. There are going to be two ducts. So it's coming from inside the room, and this one's coming from outside. And it has like a flap. So a flap that faces inwards, because so that you can push the air like this like pull the air actually, pull the air like this, but air can't go outside because now the room air is going to want to like come out of this fresh air duct without the flap. So to eliminate that, you make it a non-return kind of thing by adding the flap. So both of them are going to mix here. The cool air and the warm air are going to mix over here, and it's going to pass through the condenser, sorry, the evaporator. Oh, it's over here, my bad. The evaporator, and the fan's going to create negative pressure here, and it pushes the air towards the evaporator and cools duct A, and another booster fan at the end of duct A, which is pretty optional, but I guess I would do it anyways. And then inside the room. So yeah, that's about it. Oh, yeah, this is one idea I actually thought of doing, but I'm not going to because I'm not sure how my condenser would take it because it's pretty much made of copper and I don't want corroding or oxidizing. So what I was thinking is that, see, now the evaporator is going to form condensate, which is basically the water vapor that it cools below dew point and condenses upon the coils itself, creating water. Now this water is just when condensed, so it's really cold. So we can I was thinking let's channel this water onto, well, the eh, condenser. Yeah, channel the water onto the condenser, which would help, well, cool the condenser and increase the cooling power. Because anyways, we're going to be wasting this cooled water, so we can just use it. That's what I thought. But if the big corporate companies haven't done it, I'm not going to do it because there has to be a reason which I haven't thought of yet. Yeah, so that's about it. That's how I would build an air conditioner. Now, I think I'm gonna build this within the next 2-3 weeks. And yeah, so long. Let's see you. Let's see you after that. You'll see me after that. Huh? Okay, fine, great. Bye.